This is GATE 2012 question number 2, which states that two uniform thin rods of equal length L and the masses M1 and M2 are joined together along the length. The moment of inertia of the combined rod of length 2L about an axis passing through the midpoint and perpendicular to the length of the rod is, these are the four options, and we need to see that which of them is the correct option. So let's see what is the solution for that. So there are two rods which are given having mass M1 and M2 and with length L. Finally, what is done is that these two rods are joined with this as the intersection point, and hence this becomes 2L. The rod length now becomes 2L. The midpoint will be L and L. So this will be L, this will be L. This is having mass M1, this is having mass M2, and finally we need to find out that perpendicular to this rod at this midpoint, perpendicular to this rod, if this perpendicular line is the axis of rotation, then what is the moment of inertia at this particular axis? So for that, let us individually divide these two particular things, M1L and M2L rods. Suppose I1 and I2 are, so these are the moment of inertia of rods 1 and 2 about an axis at the end. So here suppose and here suppose respectively. Okay. So for the rod 1 having mass M1, this is having mass M2, I need to find out the moment of inertia of this rod at the end of the rod perpendicular to this rod is say I1, and here also one of the ends is I2. And it is clearly seen that if the masses are equal, then the moment of inertia would have been equal. But in this case, since M1 and M2 are different, so the moment of inertia will be different. So we will derive that what will be the moment of inertia at the end of the rod perpendicular to the rod. So that is what we will derive. But if we combine these two now, this and this, if we just combine these two, then what will happen is that it is a combination of I1 and I2. The moment of inertia finally after this combination, which we need to find out, so that this becomes 2L and this is having mass M1 and this is having mass M2. If we combine this, I will be equal to I1 plus I2. Simple, just scalar addition. So I will be equal to I1 plus I2 is what we have seen from this particular concept. Now we need to find out what is I1, what is I2. So let us see only one case, say I1, okay, having length L, mass M1, and let us say that this dr is the length element, and I need to find out I1 about this particular perpendicular axis. So let us define mu as mass per unit length. So dm is equal to mu dr. Mu in this case is M1 by L. In the second case, it will be M2 by L. Mu will be M2 by L for mass M2 and length L. So this is what we get. So I1, as per the definition of the moment of inertia, it is r square dm. So 0 to L, because from here I am taking my reference as 0 and here it is L. Okay, so 0 to L r square mu dr, because mu dr is nothing but the dm. So we have written like that. Mu can be taken out because it's a constant. M1 is constant, L is also constant. So mu can be taken out. R square dr will be r cube by 3 integrate 0 to L, and we get M1 by L, L cube by 3. So this becomes M1 L square by 3. 1/3 M1 L square is I1. Similarly, in the same way, if we proceed for this I2 combination with M2 and L, so this I2 will come out to be 1/3 M2 L square. And finally, if we combine these two rods at the midpoint perpendicular to the axis, if we want to know what is the moment of inertia, it's just nothing but the scalar addition of this I1 and I2 which we have seen. So we get I is equal to I1 plus I2, which is nothing but 1/3 M1 plus M2 L square. This should be the correct option for this particular case, where these two rods having different masses but same length are combined, and we need to find out the moment of inertia at the midpoint, that is at L from this, L over here, masses are different, and we need to find out at the perpendicular. So it is nothing but this particular point is nothing but the end of the rod of this particular rod and end of this particular rod, and hence this is the combination of these two moment of inertia I1 and I2, which comes out to be about 1/3 m1 plus m2 L square. So if we come back to this question, it is m1 plus m2 L square by 3. C is the correct option for this particular problem. Thank you.